Hello everyone, it's Dmitry Anoshin. We on the course Getting Started with Analytics and Data Engineering of Surfalytics, and today on the lesson 6 of the Model 1, we'll talk about roadmaps for data roles. So last lesson we talked about mind map. So if we look into the scope of analytics solution, we discussed the idea of using not the idea, but basically we try to touch base many different like either vendors or terms or tools or the approaches that you might end up in your career. So now, because it was all in one, so it's very hard to understand in what order you should move. So that's why the next lesson is about roadmaps. For the roles, data analyst, analytics engineer, data engineer, and couple bonus roles that you might never heard, but they're actually really applicable for us. And compensation-wise, they're still good, but they have some other benefits as well. So let's start. First, the first roadmap for data analyst. So it's basically for getting started with analytics. And my assumption that it's applicable for anyone with zero experience. The one thing that I ask everyone to know is to know a bit of Microsoft Excel. Why? Because Microsoft Excel has a very nice structure. It has rows, it has columns, and basically one sheet is a table, right? So if you can comfortably use Microsoft Excel and you can understand what's row and columns and you can do some manipulations with data, it means you're suitable for data analyst role. If not, then you probably need to do a bit of detour to learn a bit of Microsoft Excel. And by the way, end of the Model 1, we will have very nice work to build the dashboard in Excel. What you should avoid to do in your work, in real world, we'll do this here, just to make sure that everyone can do this. That's it. So, what you need to know. And here I can split on technical, non-technical skills. So I already talked about domains, and I always care about your value, how you as an analyst or engineer add the value for organizations, how you can understand what the product does, and how you can contribute to the success of organization. For this, you need to understand the business domain. And by business domain, for example, if you ask, as a data analyst, what do you do? And you can say, I'm helping increase the revenue. Okay, how you help increase the revenue? You can tell, go one layer below. I will focus on the specific metrics, maybe with a number of active users, maybe average session, or maybe number of the product checks, or number of email read, and so on and so on. So those are the metrics. And then we can ask the question, okay, how did you get this metric? And then you need those like the technical path to do this. Maybe query the data, maybe use the BI, work with database. So the business domains give you context of use of data analytics tools. Because if you want to know what you want to get, like what you want to calculate, if you want to find out number of active users, probably first you need to answer what does mean active user means. You probably heard about the story. Then Elon Musk asked the Twitter, what is user means for you and how many active users you have. And it was the biggest problem for them. They couldn't figure out what the active users means. And this is applicable for any company. It sounds very simple, active users, but from my experience, for any company, if you start dive deep into this, you probably not find what actually active user means. And then you need to get some assumptions, maybe like this number of days on the service, this number of money spent, and so on and so on. So that's business domain, give you context. And my advice here, try to do maybe digital marketing is the simplest one, or maybe mobile analytics. And yeah, it's the most popular and the simplest one. So for now, we can talk about the technical things. So you have of course, you start from the SQL. You need to know how to use the SQL. You need to know how to write the SQL. the like keywords, be comfortable. How to decide, do you know SQL good or bad? Very simple. Get any exercise on the SQL. Like, for example, you have two tables, you need to write the query to pull the data, and take paper and the pen, write down the solution. It shouldn't be 100% accurate solution, but at least you should use the right keywords and the right order, right? For example, you use select, from, you have where, you have group by, order by. You shouldn't mix them, right? If you have two tables, you do the join. Is it like left or right? You should understand if it's CTR. And we'll talk more about this on the model too. So the next one, if you're very comfortable with SQL, now you need to understand the database. In most cases, it's relational database, because you need to use the SQL to query the data, and you need to be very comfortable to explore the data. For example, if you connect the database, you first need to know how to connect the database. Then you can explore. You can see the list of the tables. Maybe it's the view, maybe it's procedure, maybe it's materialized, and so on and so on. Very rare cases, you might need NoSQL to maybe explore something from the source system backend. But this is like edge case. So, but relational database, maybe like Postgres, MySQL, be comfortable just to work on. You don't need to know the theory or like indexes or like how they work and how you host them. It's just as a consumer, as a end users of this product database, how you can query and explore it. The next one, you have to know at least one BI tool really, really well. And apart from this, you need to be able to use like any SQL client. For example, dbeaver is very good to be able to, either with BI tool or SQL client, to be able to connect the database, explore the tables, views, and manipulate. Maybe in BI tool, you need to be able to know like dimensions, measures, like how to do calculations inside, how to connect the database, how maybe live connection, extract the semantic layer or the data model. So a bunch of things. Just one BI tool really well. And it could be Power BI or Tableau. It could be Looker if you really focus on the modern data stack and your next goal to be the analytics data engineer. Visualizations, the whole like topic. Of course, you need to know some best practice for visualization, then you build and design the dashboards, but it could be complete like Super 8 job, really deep in details, how to tell the story of your data. The next one, if you're comfortable with the tool as a consumer and developer, you focus on BI administration. So BI administration, it's really competitive landscape in terms of how much value you get if you know how to deploy Tableau server. That means that you have the interview in the company using Tableau. You can talk, I have really good skills on administration of Tableau. I know how to install, how to patch, backups, how to manage the users, role-based access control, and many other things, administration. So very good things. And the last thing, because modern analytics usually host on the cloud, so after you come through all of this, you start doing like maybe some trainings, foundational trainings on the cloud. Just be familiar with it. Sometimes you might need to use statistics, especially for very popular use case, A/B testings. Like what is p-value, and even at least you should know what's difference between average and median. That's the bare minimum. But use of statistics, I never use statistics in my experience, apart from median and average use case. But overall, in some case, it could be good. What's very important is the communication and impact. So in some cases, especially if it's not BI developer but data analyst, but even BI engineer in Amazon, their impact judged by how they drive any business recommendations. Because you work in with data, you look into the data, can you provide recommendations? If you can provide recommendations, how you communicate? Like, will you do the presentations? Not best idea, but better is write the document, maybe like some kind of letter, send to the campaign, publish on the portal for internal usage. But your style, your writing style should really tell the story and make some action items. And then maybe it has the options, but it's all about the writing and communication and collaboration with other teams. So here with the yellow, I think the things that you can evolve after this. So, and typically this might take like with zero experience, like 3-4 months, because you can finish all the trainings like in 1 week. The thing is, information is really slow coming in your head, so you need time to think this. That's why 3-4 months. And it's I will cover all this information in the first three models, except the public clouds, because the public clouds will be model 5. But 3-4 months, and you can start apply for the jobs. You will fail like 10-15 interviews and you get your job. After you come to this and you land, you can start go deeper. Like you can, for example, myself, I was as a BI developer, then I start learn ETL and data warehouse approaches. So you can start learning like data warehouses, the cloud data warehouses, the DBT, especially if you're interested like the modern data engineering and analytics engineering. Of course, the DevOps, and we already start doing GitHub in the Model 0, even the containers. The coding with Python is good to have, but if you don't know Python and don't know SQL, don't learn two things at the same time. My approach, learn the SQL, master the SQL, learn the one BI tool, understand how to use one database, uh, some some extra things, how you communicate, and some key business metrics. And then if you're comfortable with this, if you land the job, you can start learning Python. But it's not enough just learn Python. You need to apply the Python. And if you don't have the job, uh, then first find the job, maybe for data analyst, where you work with the SQL and BI, and then you slowly start experiment with the Python at your work. That's we done with data analyst and BI developer. The next one, your progression towards analytics engineer. So analytics engineer for me is like I told about, it's like between data engineer and BI developer / data analyst. The thing is, you already possess all the skills that we covered for data analyst, except those yellow one. But obviously you need to focus more on the modern data stack. The modern data stack, this term is not good, the same as the big data. It's more about the tools or community or ecosystems, whatever. In our case, modern data stack, it's the Looker, it's the dbt, the Snowflake, maybe Moat, maybe Sigma, Matillion, Fivetran, those like popular modern tools. Anyway, so that's why then you do data analyst learning a work, you can focus, okay, I can learn Looker instead of Tableau in Power BI, I can learn dbt already, I can trying to see what Sigma is a BI, what's the Moat is BI, and so on and so on. So the modern tools. So if you're comfortable with BI tools, you can build the dashboards, communicate with users, you can work with data engineers, find the data, collect the requirements, and do the job efficiently. Next thing you can start doing is learn more about data warehousing. Just focus on the one platform you like. It could be Redshift, could be Snowflake, BigQuery, and try to learning as much as you can. Maybe do some tutorials, trainings, and at Surfalytics we run lots of projects for this topic. As soon as you're learning this really well, you can start basically like expanding your knowledge outside of just working with BI like this top layer, but because you're moving to the layer 3 with the storing layer. And you can, maybe you're interesting to see how you can optimize the performance. And then on top of this, you need to know really well DBT. And DBT will involve also data modeling, and usually it's a dimensional modeling technique where like have slowly change dimensions. You have your star schema, fact table, dimensions tables, and that's all incorporated into DBT. For quality testings, DBT test, or you can use another product like Sodo, like Great Expectations, the things that we just covered in our mind map. But that's the thing. For you to be analytics engineer, you need to cover this block, like data warehouse, DBT, and all the complementary things that involving. Because analytics engineer, what it means, where some business transformations exist or business logic, you need to take this logic, refine it, and create the SQL query that will keep this logic and produce the metrics based on the requirements. This is analytics engineer. Usually they don't care how the data land into data warehouse. They start working with data warehouse as soon as the data landed. And this is your bare minimum. Because DBT usually is the SQL, then it means you need to store those models in some kind of like version control systems like Git. And the quality of this like continuous integrations, continuous deployment. And we look, for example, into also lintings, the code reviews. This is all important. And for me, I already start this put in the Model 0. So if you're learning SQL right now, you already need to use Git. Every line of code you write, every note you did, all nodes you should do in Markdown and commit in your GitHub. Every SQL exercise you do, you should write and commit in the GitHub. And if you have your GitHub repo, do not hesitate to add your pre-commit things like checking YAML, checking SQL, and so on and so on. And of course, some companies, they already require you that you use some low-code ingestion tools. And my favorite example is Fivetran, because it's very easy to learn and it can do everything. Like with Fivetran, Snowflake, dbt, and one BI tool, you can build end-to-end solution very easy. And that's the project you can focus yourself with free trial accounts. You can master this thing. That's why how you basically extract the data from layer 1 to layer 3 with the tools in layer 2. That's why you always need to know my layers, because in all lessons, all courses, I will refer to the layers. So as soon, and you can like learn some ETL tools, how you transform data, how you ingest data. And this topic is important. It's really ties to like dimensional modeling and overall how you interact with dbt and data warehouse, because then you extract the data from the source. You can extract it incrementally. You could do full reload every day, dump all table, or you can collect the snapshots of the tables. So as soon as you're comfortable with this, you already can work as a great analyst engineer. Of course, any job right now, job description will have, should know the Python, but no one gonna test your Python on the interview, only SQL. And all the questions will be related to my favorite, like the main questions, the metrics, how you calculate, how you use the things, with whom you work and collaborate. So that's why I put Python ahead. And depends on your background, you can start learn Python earlier or later. This is just my approach. Because for example, I worked many years with data, not using the Python, not using the DevOps. Yeah, that's and it's totally legit case. It depends on organizations, because also usually diverse skill set inside organizations, or even just the team, very different. Someone knows Python well, someone knows data warehouse, another person is expert in dbt, another person is expert in looker. So you as a diverse team can work really efficient. That's why it doesn't need that everyone equally knows the things. So and then because if you good with the Python, you can start learning tools. And probably you already, like your organization that you want to join the analyst engineer has some of those tools. But for example, for them, you need to know the Python, because all the transformation is written in the Python. Airflow, Dagster, and Prefect. Sometimes you can work with notebooks. For example, Hex is the modern notebook. It supports the SQL. It's just a different way of writing SQL and query, like ad hoc queries with traditional SQL client like dbeaver. DeepNote, I think the mode also like supports the SQL. Maybe it supports the Python too. So as soon as it comes to all of these, the next topics you're gonna to explore is like green is a data engineering, like data ingestions in scale, like how you're gonna ingest the data with not only low code, but like any source, any tool, how you gonna put in your data warehouse. And then infrastructure. I also would like to add here, why I not forget, you can start to look, and maybe you need to do it sort of like lake house, or maybe data lake, right? Just put air or. So that's another thing that you might need to use and exploring. So now we're moving to the next role, is a data engineer. So the data engineer role is basically including the data analyst and an analytics engineering skill set, plus things that's important. So for me, some data engineers will claim we don't need to know DevOps and infrastructure. My point of view, you have to know. This is your competitive advantage. You as a data engineer should overlook the whole. As a data engineer, you need to overlook the whole thing. And so as a data engineer, you need to overlook the whole thing end to end, and it's including not just the solution itself, but the infrastructure, the cost, my favorite topic, engineering excellence, how you're gonna deploy everything and how it can work efficiently together, how like storage, processing, where you store the code, how you do the code reviews, all those things, they're very, very important. That's why it's maybe not something that you need to purely focus and learn before moving to the next topics, but it's something it should be around always while you're learning, for example, Snowflake data warehouse or just any other data warehouse platform or ETL tool. You need to use those things and keep them in mind. How you're going to deploy it, what's about security, networking, infrastructure as a code, all those things matter. Yeah, the cost analytics solution, just put it separately right now. Everyone cares about the cost because, like economic situation not good. This is really good cases to look in your organizations, to talk about interviews, how you cut the cost, because AWS billing provide, for example, AWS, Azure, same, just they provide you billing for all services down the second, for the compute, for the storage, for the services you use, any kind of the product you use, you have the license codes, the number of people, and so on and so on. So architecture, the next one is architecture understanding. So for me, it's very important topic for all roles, but here you just must have. And usually it's my layers, right? Then I can, for any projects, any organization, I can map into layers. I can see what tools they use, how they work, and maybe you can also look like in the source layers particular, what kind of what kind of backend teams they have, how they work, what's the volume of data. Now we can moving to the next topics, data modeling techniques. Yes, the data engineer, you definitely, if analyst engineer, you may know, dimensional modeling may not know well. Here you need to know because somehow you need to build this data warehouse or in other like data lake house, and you need to know how you're going to model the data. So the analytics engineer, this role may exist, may not exist. Many companies just avoid this. For example, there is no analyst engineer in Amazon, Microsoft, and probably some other big companies. Some companies, they don't have data engineers, they have analytics engineers. So it uh, could be anything. In my case, you could think about that analytics and data engineer is the part of the whole thing, and just progressing from one to another. And I give you like the simplest path that like 20% of the skills can give you 80% of result. So the cloud data warehouse, like implementations, performance optimizations, of course it's MPP, right? Massive product processing, distributed data warehouses. You should know definitely more than one warehouse, maybe like Redshift, BigQuery, Snowflake, uh, maybe something else like ClickHouse, DuckDB, what's the use case, and so on. So testing and quality, very important for every data pipelines, everything you do. You need to ensure about testing and quality. What kind of frameworks, how we can ensure the data is good, and so on and so on. So documentations. Documentations also is important, and it may look like that documentation is important for all roadmaps, but it looks like the data engineer is a last resort. If like data analyst didn't do this, analytics engineer didn't do this, it means the last resort is the data engineer. The next one, as soon as you're comfortable with your data warehousing and like all techniques to make your data warehouse projects successful and good quality, you can start learning big data tools. For example, it's everything related to Hadoop ecosystems. There is Hive, and there is could be many other things. The Hadoop itself, like in public cloud vendors like with Elastic MapReduce, Azure HD Insight, Google Dataproc, those like Hadoop, native Hadoop, like or managed Hadoop systems, they still in use. And there are some other like tools related with these managed Hadoop in the cloud. So Apache Spark, I put ahead of data warehouse because I believe let's just first focus on the data warehouse, understand how it works. Soon we comfortable understand, we can start learning Spark. But again, it really depends on the role. Some organizations, they don't use data warehouse at all. They use data lake and process all the data Spark. They have the Spark transformations. Some people, they even going crazy and they use the DBT with Spark because it support Spark SQL. So after Spark, you're going to the term like Lakehouse. And despite the fact that Snowflake is Lakehouse technically, but I'm more focused on like through Lakehouse like Databricks. And by Lakehouse, I mean you basically need to understand in mind map, I highlight like formats like Delta, Iceberg, and Hoodie. You need to know at least one of them and try to do this. So the approach of data lake, it it's all like ties here, but it just doesn't matter what's the order of SQL. And we can even put it. This can connect it to here is like additional tree. So, and as soon as you come, and this is all, by the way, we talk about the batch processing, and then you can do the streaming. So, ever advanced use case, it's machine learning for someone who interesting. At least you need to know how you can interact with machine learning team. Right now, any organizations they have machine learning initiatives, so data science initiatives, or even generative AI initiatives. So as a data engineer, how you can be helpful? Can you help on building infrastructure? Can you help on ensuring the quality, or maybe building the feature store? So the more use cases you know, the better you can understand how with your skills you can help those teams. So that's basically it for 3 key roles. This is all will be covered in my course. This is all what I can help you to master and learn. This is all what I know really well and I'm doing for the last 15 years, either build or help people to get the knowledge with like the shortest possible path to actually get this role. And you see, on my blogs, I'm quite vendor agnostic here because it doesn't really matter. I'm more focused on fundamentals of those things. So, and now the bonus. The bonus 2 roles that you might not even imagine that they exist. The role number 1 is support engineer. So we talk lots of vendors like Databricks, Snowflake, um, Tableau, Power BI, Azure, AWS products, Azure products, Google products, Looker, so many products. If you paying money to use the product, it means you have support. You also pay actually for support. If you have any kind of problems, usually sometimes you have the questions, I don't understand how it works, or maybe you're trying to connect from Looker to Snowflake and you have failure. Uh, they you will write support ticket. Who will answer support ticket? Support engineer. What skills support engineer should have? Obviously, if you create support ticket for Snowflake, they should know something about data warehouse. They should know how they like a bit of data engineering skills, maybe data analyst engineer skills. So they need to know the industry and the tools, but their compensation level very often same as a data engineer or analytics engineer. 30% or more they spend on learning. They know all recent features of the product. They know excellent the product. They have access to all resources inside the organizations for free, all the trainings, all the certifications. So you will be probably, if you work as support engineer, any kind of those kind of company like Databricks, Snowflake, Tableau, Looker, you'll be absolutely expert on this tool. This is one. The second, you will know all the features, and yeah, it just I can go and go about benefits, and the way how you work is very different because you don't have deadlines, you don't have the projects, you don't have sprints, you don't have anything at all. All what you have is the ticket from the customers, and you have SLA to response for the ticket. Maybe it's like depends on severity. It could be 1 hour, it could be 1 day, it could be I don't know 5 minutes, right? Depends. And the only you need to respond, and then you need to provide the response. The customer, maybe you have the call, maybe you email, but you need to solve the customer problem. You directly, the biggest impact you might have as a working organization is impact on the business customers. In our case, you only work as support engineer with the customers. So you do your work well, you know the product well, you solve problems quickly. You can always escalate to the product team, bring the other engineers. But if customer happy, you can progress your career really fast, and you probably will grow way faster than like traditional like data engineer, analytics engineer. So this is one. Uh, so the next one is sales engineer. So the same, all those vendors that I mentioned, they usually then they sell them to the customers. They want to like sales a salesperson or a sales manager, sales executive, whatever. What they're doing, they talk with the customers. They're trying to sell, convince them to spend the money on tools. Like probably the most successful sales stories we know from Snowflake. But anyway, just talking not enough. You need to show the demo of the product. You need to answer technical questions of the customer. You need to maybe tailor the demo and so on and so on. Who doing this? They doing like sales or sometimes it's called pre-sales engineers. So that's another interesting job. Again, you obviously need some skills to know in this field, have some experience work in the past. But again, you know the product really well. The downside, different from support engineer. Support engineer, you can work anywhere in the world, and you even your shift could be like on the weekends or maybe evenings or maybe mornings. Here you work through traditional hours, but you might have travel to the customers a lot, and you might like go to the conference if there any conference or any kind of organization events. So overall, it's very good position. Personally, it was my dream position in the past. Then I was younger, didn't have many kids, because I even tried to be as a like sales engineer in Tableau. Once I got offered as a sales engineer in MicroStrategy back in Moscow, Russia, but then they closed the office, unfortunately. So the benefits, you know product well, you never go deep into the project. Like some projects can go like for years, implementations of data warehouse. Here you interact with the customers, give the demo, everyone happy, you move next. You're just enjoying. I think another role that just coming to my mind while we're talking is Evangelist. You might see Evangelist, like product evangelist or like product advocate. This role is you need to engage with communities. And I know like Astronomer has one, DuckDB has one, the Snowflake has one. They're also very good roles again, but I think this is very hard to get it from like ground up. You probably should be first have the decent experience of like data engineer or analytics engineer or data analyst before you can, and you should engage a lot with communities, and then the vendor can hire you. I don't know anything about the compensation structure. I know they travel a lot. They talk about new features. I really admire people who doing this work because very active. I would say they're very proactive. They come up with new cases, new blog posts. But again, that's something to consider. Just out of the box. That's it for me. Thank you. And we'll have one more lesson before we about history of the tools and their evolution. And then we will do talk a bit hands-on of Excel experience, and we're done with the model one. See you everyone.